Question 12, Part B. The diagram shows the rhombus OABC. The diagonal from the point A, 7, 11, to the point C lies on the line L1. The other diagonal, from the origin O to the point B, lies on the line L2, which has the equation y equals negative x over 3. Part 1. Show that the equation of the line L1 is y equals 3x minus 10. One of the properties of a rhombus is that its diagonals bisect each other at right angles. Now, line L1 and line L2 represent the diagonals of this particular rhombus. And since they bisect each other at right angles, that means line L1 is perpendicular to line L2. That implies that if we take the gradient of line L1 and multiply it by the gradient of line L2, we'll get negative 1. Now the equation of line L2 is y equals negative x over 3. So it's in the form y equals mx plus c. So the gradient of line L2 is equal to negative 1 over 3. So to find the gradient of line L1, we take the negative reciprocal of negative 1 over 3. So negative 1 divided by negative 1 over 3 is equal to 3. And that represents the gradient of line L1. Now the point A, 7, 11, lies on line L1. We have a gradient, we have a point. So using the point gradient formula, its equation is y minus 11 is equal to 3 times x minus 7 in brackets. Expanding the right-hand side, we get y minus 11 is equal to 3x minus 21. And then adding 11 to both sides of the equation to make y the subject, we get y is equal to 3x minus 10 as required. Part 2. The lines L1 and L2 intersect at the point D. Find the coordinates of D. To find the x-coordinate of point D, solve simultaneously the equations y equals negative x over 3 and y equals 3x minus 10. Using the substitution method, we can form the equation 3x minus 10 is equal to negative x over 3. We can eliminate the denominator 3 by multiplying both sides of the equation by 3, and the equation becomes 9x minus 30 is equal to negative x. Now we can move the negative x over to the other side, it becomes positive x, so 9x plus x is equal to 10x, and the negative 30 on the left-hand side can be moved over to the right-hand side, it becomes positive 30. So the equation becomes 10x is equal to 30, then dividing both sides of the equation by 10, we get x is equal to 3. Now the point D lies on both lines L1 and L2. So to find the y-coordinate of point D when x is equal to 3, we can use either one of these two equations. So when x is equal to 3, y is equal to negative x over 3, which equals 3x minus 10, which equals negative 1. Therefore, the coordinates of point D are 3, negative 1.